to pick up where I left off in that last video. I'm going to start off with Sal Khan's video on YouTube that you guys saw. This is the work that he provided. Notice they're only giving you a piece that you're interested in. It says start at x equals 1, end at x equals 3. And these are the 1, 2, 3, 4 boxes that he found that would approximate his exact area under the curve. Okay, so if you'll notice, they found that if they added up the boxes, they got 8.75 as the area, and the actual area of the curve was 10.667. So if you were to shade all of this region underneath the curve from 1 to 3, then you get 10.667. Okay, so I want to direct your attention to another part right here where you'll see it says add up the heights times the base. So you're trying to add up the area of rectangles in order to get there. Okay, so let me show you the one that I just did in my video. Okay, so here's the one you saw in my video where I did the right sum, and they did the exact same sense in that they did height times base again, and they add the area of this rectangle to that one, to that one, to that one. Okay, so please see my work. Okay, so you'll notice that they have found out that when they add up those rectangles, it's 12.75, which is too big because the actual area of the curve is 10.667. Okay, you look down here, how'd they get their answer? They added the height times the base. Okay, now I'll show you what I plugged in. I got this on the Wolfram website. Okay, so I plugged in x squared plus 1 as my function. I said start at x equals 1, end at x equals 3. 4 rectangles, and I'm going to use the right sum. We only use right and left sum in this class. Okay, so then the question that I would ask is, what would happen if I use more rectangles? So what if I go over here, instead of using 4 rectangles, I use 10 rectangles? Okay, so let me replot that, see what happens. All right, so you see I get an even better approximation than what I got 4 rectangles. So I'm going to try to do 100 rectangles. So I go over here. Okay, if you go to Wolfram and then type in Riem Sums, RIEMANNSUM, look, there's 100 rectangles. So by going from 10 rectangles to 100 rectangles, you get an even better approximation. It gets you closer to being able to get the exact area under the curve. By the way, this is what I mean, Riem Sum. It means add the area of the rectangles. So if we use 1,000 rectangles, we should get an even better approximation. So let's go over here, plug in another 0, replot this. Not sure it can do 1,000. Let's see. Oh, look. The rectangles are really, really thin, but they put 1,000 rectangles from x equals 1 to x equals 3. So the point is that if you use more rectangles, you get a better approximation for the area under the curve, right? So that's going to be key to your understanding of what is occurring. All right, I'm going to backtrack just for a minute so that you guys can see exactly what I'm doing. Okay, so in this problem, our goal was to use boxes in order to find the exact area under the curve, right? We want to find this exact area under the curve, right? This ends up being an over approximation because the boxes are too big. Okay, and what I just showed you showed that if you use more boxes, you get a better approximation. But this is the general formula that you would use. Add up the height times the base. But you would only use this formula if you know the number of boxes. So if you know you have 10 boxes, or 15 boxes, or 25 boxes, or 90 boxes. But what would happen if you have an infinite number of boxes? It would look very similar to what you saw on the screen if you have 1,000 boxes. So the notation that you're going to use when you have an infinite number of boxes is this integral, right? The antiderivative represents that you're adding up an infinite number of boxes. And what are you putting? You're taking your height. That's what f of x is. Determine your height times your base. Delta x. Look up here. Delta x. So every time you find an antiderivative, you are adding the height times the base. Just in this case, you have an infinite number of boxes, so your answer is going to be exact. And here, you have a finite number of boxes, so you're still going to be approximating. So please keep in mind, this dx, it represents the base of your box. The f of x represents the height of your box. And then this integral says add up an infinite number of what follows, height times the base.